In this episode of Hot Hardware's 2.5 Geeks, we're talking all things Intel Panther Lake with a very special guest from Intel. Next. Welcome back, ladies and gentlemen, brothers and sisters, to another wonderful episode of Hot Hardware's 2.5 Geeks live stream. I'm Dave Altavilla here on a sunny Friday in New England. With me, as always, is my effervescent and always entertaining compatriot, Marco Chiappetta. How are you, my friend?
I'm doing okay. That's a great introduction.
Always entertaining and always entertaining and interesting is Nish Neelalojanan from Intel. I hope I got that close to right, Nish. Welcome to the 2.5 Geeks live stream. How are you?
I'm great, thank you.
Thanks for
I'm in sunny California.
Yeah, that's it. We have a little crisper air, I think, out here in New England than you do, perhaps, where you are in California. But we appreciate your time. Nish is Senior Director of Product Management for PC products at Intel. So very close to the new processor platform. We are affectionately codenaming Panther Lake, or Intel, I should say, is officially codenamed Panther Lake. Nish, you're a first timer with us, which is great, by the way. Great to have a new face and a new personality from Intel joining us here live. But why don't we start with you? We're going to get to the product for sure. Let's start with you. And then Marco, we're going to come back to you for some ground rules for the chat as well. But Nish, your role, Senior Director, Product Management, PC Products at Intel. What's your purview? What's your background? What do you do there for the good folks at Intel?
So I manage the product management team, which takes care of all of the different PC products. And I was fortunate enough to be involved with Panther Lake from early on, from the definition phase and all the way up now. Now we're going to let the baby into the world there. So I am very excited and passionate to talk about Panther Lake. It's finally we get to talk about it and tell it to the world.
Awesome. Yeah, no, we're excited too. I think a lot of folks have been waiting for this moment, built on Intel 18A, which is another important moment in time for you folks as well. Marco, why don't we set some ground rules for the folks in the chat, which folks, by the way, we can get your questions answered if you're nice, right, Marco?
Yeah, absolutely. So we're not here to get anybody in trouble. And obviously, Nish is not going to disclose anything that is not already public. So you can ask whatever you want. We can't guarantee everything is going to get answered. And it looks like we already have a couple of dozen folks on Twitter. The comments don't necessarily update in real time if you post a question on Twitter. So if you want to shoot over to YouTube, that's the best way to submit a comment. They come in basically in real time. And same for anybody watching on LinkedIn. We don't always see those comments come in through our StreamYard interface. So if you want to interact live, come on over to YouTube.
And we can even show your comment live on stream like that. See that? That's a comment.
Exactly. And, keep it respectful. Nish is here donating his time. Be respectful and, keep it clean. No trolls welcome.
We don't subscribe to trolls. No, that's never good. But Nish, you look like, you're smiling, you're dancing a little bit today. I know the actual launch is coming in the coming near months. I think it's maybe closer to CES time frame. But let's talk about Panther Lake. Maybe you could give us. Marco was out, by the way, at your Arizona facility, Fab 52, blown away, by the way, with the sense of scale. We'll get into that as well. But let's start with Panther Lake. Let's talk about the processor, what it's all about, maybe a high level on how it differentiates versus previous gen products, and what it means for the industry in general.
Yeah, for sure. So I'm sure now you guys have tested out Lunar Lake, and some of your audience probably have too. So with Lunar Lake, we busted the myth that x86 cannot be as efficient as ARM. So Lunar Lake was a tremendous leaps forward in terms of efficiency, a battery life, getting all-day battery life. We had very good multi-threaded performance with Arrow Lake. And with Panther Lake, our challenge was to take both and put it in one package and make it scalable so it can reach multiple price points, but also offer different choice points so the users can get what they want. So this is what we did. Our engineering team took that challenge. They were able to take all the good stuff from Lunar Lake and Arrow Lake, put it in. So Lunar Lake efficiency, Arrow Lake performance, all in one scalable setup die package combinations, which offers more scalability in price points, and also it offers more different choice points, and we'll talk more about those choice points.
Boy, I tell you what, I'm digging the Panther Lake shirt. I think I need one of those.
Wait, the most important question before we start, did Tom Peterson ever get his T-shirt? He was really upset at Detector that he didn't have one of those shirts.
I'm sure he did, but like we say, I know a guy. I can hook you guys up.
Excellent.
He knows all of them too.
So let's add this to the stage. And Marco, I know you've got a bunch of burning questions, but this is kind of the summary slide. Well, it's not kind of, it is the summary slide for Panther Lake. As you mentioned, Nish, built to scale for lots of different platforms in the laptop market, the mobile PC market. Marco, what do you got on the top of your mind? And then, of course, we'll field some questions as they come in from the chat.
Yeah, I think first off, I'm going to quickly set the stage. If you haven't been by hothardware.com yet, we have a multiple page article outlining lots of what we saw with, a deeper dive on Panther Lake, Clearwater Forest, and Intel's Tech Tour, and our tour of the fab. So if you want to dive deep, hit hothardware.com, check out that article. We just popped it into the chat if you need the link.
And there it is.
And just some quick background on the Intel Tech Tour. A couple of weeks back, Intel held an event where media and analysts from basically around the world, we got to experience the Intel fab facility in Arizona firsthand. Right, I was inside the fab. We got a great tour of the fab, and we got the deep dive talks on Panther Lake, all of its various engines, and on Clearwater Forest, which is the next gen Xeon 6 Plus server platform. So tons and tons of information came out of that event. We're going to focus on 18A and Panther Lake here. So, so let's get to like the first real question for Nish. Why don't we just start with something basic? Why don't you explain the three different Panther Lake configurations that are coming to market when the product launches?
Sure. So like I mentioned, we wanted that scalability, so that could be end user choice point. So we have our base configuration, which is 8-core, similar to Lunar Lake. So it has 8-core in terms of 8 CPU cores, and that is 4 performance cores and 4 low power E-cores. And then we have 4 graphics cores. So that is our base configuration. Then we have a 16 CPU cores, which would be a 4 P cores, 8 E cores, and 4 low power E cores. So that adds up to that 16 cores and 4 graphics cores. So this is, if you take the base configuration, that is great for your day-to-day productivity, everything. If you're an office worker, it gives all the performance you need for your day-to-day productivity needs, and also it gives that super long battery life which Lunar Lake offered. Then the 16 cores is now, if you're doing more compute scientific workloads, you will need that 16 core. So you're crunching out Black-Scholes algorithm, Excels, multiple Excels, then that 16 core will be useful. But we also have incremental PCIe lanes on that 16 core 4XC or 4 graphics cores that enables discrete graphics. So if you're a gamer, you want to have big discrete graphics attached to it, then that would be the configuration also you go for.
Nice.
And the last configuration, of course, is the 16-core 12XE. This is the large integrated graphics configuration. So think of this as if you have big AI workloads, you have the muscle from the 12XE. So up to 180 platform peak tops. But if you also wanted that sleek gaming, sleek creation experience in that small, thin and light form factor, this big integrated graphics configuration offers you that opportunity. So that is kind of the three different choice points you have for the type of based on the type of user, you can go pick and choose.
Gotcha. And sorry for that rough transition there, Nish. Put the 16 core 12XC variant back on the screen for you there. There it is on the far right. Boy, a lot packed into it, a lot to unpack with Panther Lake for sure. Marco, you want to keep teeing up some more questions? I've got a couple of my own as well.
Yeah. So let's, AI is obviously a big focus. These are going to land in next gen AI PCs. Can you talk about Intel's, platform AI approach, what Panther Lake means for next gen AI PCs? What kind of experiences can people expect?
Yeah. So if I say AI 3 times, Intel stock goes up. No, just kidding.
So, you got to say it a lot these days. Go ahead.
Our approach is a platform approach. So we have carefully taken and integrated enough AI in the right engine so that for the different type of platform use case, so if you're using a PC, you're getting the most out of it. So the starting point is obviously we have it in the CPU. So this is for anything which you don't want to go outside the flow of stream and reduce the performance, or OS type workloads, or something like a Tableau workload where there's small amount of AI, but it's still kept in the same workflow, then that's on the CPU. AI can be utilized. Then we have the NPU. This is the low power engine, e-core of AI. So if you're doing some background tasks, AI agents running in the background, always running, taking low amount of power, that would be that NPU. And then we have the GPU, which is your muscle, where this gives you that bursty big performance. So if you're doing video creation, AI generated video creation, and you want that significant amount of performance to push through, that will come from the XMX engine or XMX AI engines built into that integrated graphics. So these are the three main places, but we've also sprinkled on, for example, in our IPU, which is the camera, the image processing unit. So if you have real-time camera feeds and you want noise suppression, you want really good quality video, even in low light situation, we have some AI built into that. We have some AI algorithms built into our Wi-Fi chip. So there is AI sprinkled across platform. So we have this mindset that a best AI PC is a great PC first. So Panther Lake is going to be an amazing PC, and it has AI scattered across in all the different engines to be utilized in the right way.
Awesome. And actually, let's just put the NPU 5 up real quick. Talk about that since we were talking AI, and we can dive back into some of the questions we had. But NPU 5 is a 50 tops NPU versus, I think, what is 45 on, or was it 48? 45 on Lunar Lake, right? Yeah. So, a modest upgrade in terms of total tops, but there are other improvements here, other performance and efficiency improvements, right?
Yeah, so like I said, we carefully put AI. We did not want to just overload one engine because it. So I'll first talk about the NPU and I'll hit back the platform. So from an NPU perspective, we have some area efficiency. So we've built it so that we have 40% reduction in terms of area or tops per area. It's a lot more efficient compared to what we had in Lunar Lake. Like you mentioned, there's only a modest couple of peak tops improvements from what we had in Lunar Lake, but shrinking this meant we can pack other capabilities into Panther Lake. But compared to Arrow Lake, of course, it's a significant jump because from Arrow Lake, it's almost close to 4 times the peak tops we had. But like I mentioned, we were focused on platform peak tops. So that means we have XMX engine in our 4XE and 12XE engines. That means your total platform peak tops on our 4XE products, 8 and 16 core, is close to 100. And then our 12XE is about 180 peak tops. So there is significant amount of AI power built into it, but it's split across. And just another data point, I think in some of the ITT things we touched upon it, that majority of the applications today are not building for one particular engine. They are using the right engine, which makes sense for them. So there is a significant amount of ISVs building to that integrated graphics, because you are able to get to that big, large system memory, but also that burstier performance, which is going to give them a lot more efficiency when it comes to that AI performance. So there is a lot of ISVs building across, and this platform approach allows us to give the best AI experience. So this is why you'll see tons and tons of AI applications running on Intel for much quicker and also in large scales.
Yeah, I think you folks have certainly established a leadership position with respect to software enablement of the AI ecosystem as well. So that's good stuff. Marco, why don't you dive back in, and we can also we should also get to CPU cores and GPU cores soon as well, right?
Yeah, well, before we get to that, let's go to the transistors really quick, right?
Okay. All right.
Part of the big story with Panther Lake
yes.
is that the compute tiles are manufactured on the Intel 18A process, and the 18A process has new transistor technology, new power technology. Let's talk about a little bit of what what 18A means for Panther Lake.
So as always, right, we want to leverage every single toolkit in our toolbox. So we look at it as we have process, we have packaging technologies, and we have our architecture. So our engineering team has taken all that goodness, and we have used the right manufacturing process for the right tile to be able to get the best out of it, whether it's scalability, whether it's the right level of perf per watt, etc. So we have chosen, or whether it's faster time to market, all of that put together, we made different process choices, but that combination of all three, like three legs of a stool, is what's delivering on Panther Lake. So that is essentially the summary of, we've taken all the tools we've got and given the best combination of that we can with Panther.
That's great. And, I actually, that was one of my takeaways of the 18A side of it. The reason you folks held this at Fab 52 in Arizona was that Intel was making a significant bet on their next generation, very important, next generation CPU architecture for PCs. And the compute tile is core to that. Certainly some other tiles you may have, chosen other processes for efficiency, and as you noted, time to market, what have you. But that's a significant bet. And it is a testament to the fact that, 18A is alive and well and yielding well and all that good stuff, right?
Yeah. All of our compute tiles are built on 18A for all the reason you said. So definitely. And I just wanted to do, the packaging is also done by our manufacturer. Yeah. We are able to take its advanced packaging. This is something our IFS, we call it our manufacturing part of the company, is leading with. So we are leveraging both of it to be able to give Panther Lake along with the architectural prowess our product architects have.
Yeah, definitely one of the unsung heroes of chip manufacturing is packaging technology. It is so critical, and you folks are world-class leading in terms of packaging, whether it's Foveros or EMEB or all these different technologies that you incorporate yourselves. This isn't another manufacturer. This is all internal capability for these multi-die chiplet systems. So good stuff for sure. Good stuff. What else you got, Marco?
Well, we're going to take a quick tangent. We'll come back to quick tangent because we had 3 questions build up in the chat.
Right, we did.
Sharath in the chat. There's 0 chance that question gets answered, so I'm not ignoring you, but we're not going to waste Nish's time with that question. And for quick clarity on the 50 tops for the MPU and the 180 total tops, at what precision level are those numbers from? Is that FP8?
Good question.
Yeah, it's Intel.
Intake.
Oh,
Yeah,
intake.
okay.
There you go. So those tops numbers for Francois, that's asking intake numbers, and then just unrelated to everything we talked about so far, but related to the platform, we had Enoch ask. He wishes Intel integrated Thunderbolt 5 into Panther Lake. Can you explain how Thunderbolt 5 will play into systems and not necessarily the Panther Lake chip itself?
Yeah, I mean, in general, that high amount of bandwidth is going to be at that high-end workstation or mobile workstation type of platform. So we have Arrow Lake HX. So our Arrow Lake HX platform, we have it at the top, which is going to go into a lot of these mobile workstations. And those high-end platforms will have Thunderbolt 5. Now, if an OEM wanted to, they could take and put in a Thunderbolt discrete with Panther Lake. There is no stopping, but highest level, we have carefully chosen the right feature set to fit into the right product category so that where it will play the most. So there will be some we integrate, some we need to have as discrete components.
Yeah, I think some folks don't. I think some folks don't appreciate the fact that it's always a trade-off of silicon area and power budget too, right? So if you start putting in, bleeding edge connectivity I/O, at least at this stage of the process and die geometry or whatever, it's not always a slam dunk to just say, oh yeah, let's throw that in too. Let's just get the kitchen sink, throw that in, and so it's a line to walk, right?
It is.
Yeah. Okay.
So let's dig back in. Here we go. So there's obviously lots of messaging about performance and efficiency with Panther Lake. Can you? I know we can't disclose like actual benchmark scores, et cetera, just yet. But can you talk a little bit about expected battery life performance and also performance on AC versus DC? What kind of experience users can expect?
Yeah, we can put this up too, so we can talk to that a little bit.
Yeah.
Yeah, so we will absolutely. First of all, I think in terms of I'll head the performance question because I've not looked at the chat, but this may come up. We are going to share tons of performance data as we get closer to launch, right? So stay tuned. A few more months, you'll see tons and tons. And in a few more months, there's going to be a lot of reviewers having Panther Lake in their hands and be able to test it out and give their own opinion of that itself. So it's a few months out. We'll definitely share a lot more. But what we can say, we are super excited is one, like I mentioned, we took Lunar Lake efficiency. So to answer your question in terms of battery life, you could expect Lunar Lake like battery life. So there's tons of lot of data. I think there's an article just came out even today, which talked about how Lunar Lake is very close to Apple-like efficiency, Apple-like battery life. So you could expect that with Panther Lake. But then on top of that, in terms of performance, you could expect Arrow Lake-like multi-thread performance. So what I mean by that is about 50% better multi-threaded performance compared to Lunar Lake at the same power level, or Arrow Lake like multi-threaded performance, but at 30% lower power level. So that's kind of the highest level how I can describe in terms of the performance and the efficiency putting together. Did I answer your question, Marco, or?
I think so. I think that's a very good answer.
Let's talk a little bit about, and we can add it back to the screen, but let's talk a little bit more about Darkmont. That's a new E-core and low power E-core architecture. It's different than what we have currently in Lunar Lake. Maybe could we double click a little bit on that?
Yeah, so true to my theme of borrowing from both of our previous architecture and making one scalable. So we have Cougar Core. It's an improvement. It builds upon Lion Core architecture, which we have, the P-Core architecture, which was Luna and Arrow. But we are increasing our L1, increasing our different cache levels all the way up to L3 cache is increased compared to what was on Lunar Lake. So L2 and L3, I'm sorry, not L1, L2 and L3 caches are increased compared to what we had on Lunar Lake. And we are then able to bring the low power island. So we have a performance cluster, which is where our Pico and Ecos reside. So these Ecos are able to tap into the L3 cache, as I said, the large L3 cache. So this is an improvement. This is similar to what was in Arrow Lake levels, which was not in Lunar Lake levels. We brought it there. And then when you go to the efficiency cluster, where we have low power, where we have our efficiency cores, in that efficiency cluster, it has access to its own resources, which means when you're browsing, when you're doing day-to-day productivity, we can shut off the rest of the cores, rest of the complex in the CPU core, which means your battery life is going to significantly improve. This is similar to what was in Lunar Lake, which is what we are bringing with Panther. So we're taking a bit of both, we are putting there, and then on top of that, our Darkmon E-Core has a lot of improvements when it comes to throughput, when it comes to L2 bandwidth, and also some improved DPC, and we've also introduced DPC to Darkmon itself. So much better E-Core, and then bringing all the goodness on the different Pico implementation into our P-Core, and then having a architecture similar to what we had in Lunar Lake and Arrow Lake, putting them all together is where you're getting both the efficiency and the performance.
And that probably, I would believe, is how you got to the point where you have much better performance on battery as compared to plugged in. You guys have worked hard on that, right? And managing power for that state.
Indeed. Thank you. You asked a question before, and I did not answer that. So thanks for the hint again. So
that's all right.
That was something which we have done along with not just the hardware level. We also have improvements across our what we would call P-code firmware and OS level. So what we have as Thread Director, Thread Director, this is able to optimize a lot of the hardware things which we have underneath. So we have zones, which is called an efficiency zone, where it only tags all the threads to the low power E-core. So like I said, when you're doing your day-to-day browsing, web browsing, or tasks like Teams call, it will put on the low power island or efficiency cluster, and you're able to get that increased battery life. Then you have another zone, which is the hybrid zone, which would put it on the P and E-core, the performance cluster. So you're able to get more performant or that balanced level of tasks. Where you need you're creating a photo and you're putting some effects. So Marco, if you wanted to put a hat on your artificially in Adobe on Photoshop, then it's a simple, that hybrid cluster will kick in and give you that performance for that effect and then shut itself back down. Now, if you want the full multi-threaded performance, use all the cores, we call it zoneless, and you're able to go all in, get all the full all the cores flaring up to be able to give you that full-on multi-threaded performance. So net, there is different zones with our OS clustering, and the Thread Director manages it. And the way it's able to pin it in the right core gives you that improved battery life. And this is something we are also working. There's advanced tuning capabilities which we have added with Thread Director, which is able to give that balanced, even in different OS settings, to be able to give that best performance and battery life combination. And as a result, like you mentioned, both on AC and DC, we are able to give that really good performance with whatever the power levels you have. So all the OS slider settings, there is a lot more software improvements behind the scenes to be able to give you the best performance in whatever the mode you have chosen.
Awesome. Good stuff. Good insight. Marco, you want to dive in for some more?
Yeah, let's stick on the topic of the E-cores for a minute. With Panther Lake, the E-cores with Panther Lake and the way Thread Director works, the e-cores, they're not only more performant, but more workloads will sort of prioritize e-cores first. Let's talk about what would run best on there. What are they capable of? For example, can you use e-cores for gaming, right? Let's talk about how the workloads are transferred across the different zones and what workloads run well on the e-cores in particular.
Yeah, so the e-cores are capable of running a lot of performance hungry workloads. It can dip into the L3 cache. It has DPC added. So as a result, when you're in power constrained environment, like in a laptop, if you have game threads which can be prioritized on the eco, which is something we are actively working through with the ecosystem, that means you're able to give more headroom to the other parts like the integrated graphics. That means you will be able to get overall better performance. So this is going to be depending on the app dependent, but there is definitely going to be benefits where you can put some of those threads onto that e-core so that it can free up resources for other things and you will get an overall better performance. So that is one way that e-cores are helping to be able to get overall better performance, but that efficiency of the e-core helps with it.
Got it.
Gotcha.
Got it. Good stuff.
Should we move on to P-cores a little bit?
Yeah, let's P-core it, man.
All right, so the Cougar Cove P-cores, they're not like a complete departure, right, from line code, but obviously they're built on a new process. You guys, it's not a copy and paste, right? There's things that had to change. Can you talk about some of the things Intel did to improve performance, efficiency? What kind of enhancements were made with Cougar Cove?
Yeah, so like I mentioned, we compared to Lunar Lake, what was in Lunar Lake Lion Cove, we added increased MLC and last level cache, right? So our from 2.5 it goes to 3 megs on MLC per core, and then in terms of the last level cache, we have increased that from 12 to 18. So that on its own reduces the need for CPU to go back and forth to the memory, which means you're getting better performance, but also you're not going and waking up and you're constantly going back and forth. So in some use cases, you will also get better battery life. So net result of that is that is where those are some of the improvements we've done overall. And like you said, it's also designed and optimized for 18A and getting some of those benefits too.
Gotcha. Very cool. Quick tangent. We got a question from Twitter. I'm not sure if you guys disclose this or if you can disclose, but I'm going to ask.
Good question.
Pretty straightforward question.
Yeah.
We Sounds Nerdy on Twitter is asking what the overall TDPs will be for the Panther Lake SoCs.
We have not disclosed it, but you could expect a big range, a broader range. Overlapping range because of the efficiency. There will be a lot of overlapping range, but somewhere what Lunar Lake was able to cover, and also what Arrow Lake was able to cover. So there will be a range, but we will talk more about that as we get closer to launch.
Related question, is it fair to say we'll see Panther Lake in a similar range of form factors that
Absolutely.
Lunar Lake was in? Okay.
Lunar Lake and Arrow Lake, so it has that flexibility. So depending on the die package combination, you'll see it in one or the other, but yes, it'll cover the full breadth.
And you know, I should also mention, if you hit the channel, like if you're watching on YouTube right now, when we're done, don't do it now, stay on the feed. But I recorded 3 different demos that Intel had running at Intel Tech Tour. So Panther Lake in robotics, Panther Lake used for an intelligent teleprompter, and we got to see Panther Lake gaming showing multi-frame generation as well on the Xe3 GPU. So not only is there new hardware coming, Intel also has new features coming in their graphics software. So check those out after this stream ends. There's that. Yeah, it's really cool to see the chips in action.
We'll link them in the comments so folks can just hit them in the comments of the stream as well. Do we want to talk a little memory? Want to talk a little memory before we go to GPU?
Sure. Why not?
Yeah, why not? Let's add that. LPDDR5 memory up to now 9,600 mega transfers per second, up to 96 gigs. And then, you know, I guess maybe the baseline configuration, 7,200 mega transfers per second, 128 gig. Comments on that? It seems SKU dependent. are we talking the highest end, highest bandwidth memory for the more, I guess, desktop replacement class machine, or how's that going to map out? I guess, can you speak to that level of SKU configuration and device alignment, I guess?
Yeah, so in terms of the LPDDR5 or 12xe part, big graphics part, integrated graphics part, will support the highest LP memory. So this is because in terms of the overall bandwidth needs, and also the size up to 96 gig is going to be interesting because even discrete graphics out there, they are going to be memory bound. So the biggest is, I think, 24 gigs out there, right? So because of the large system memory, there is going to be ISVs which can do or run bigger models where the integrated graphics has good enough performance, and when it comes to AI performance, and it has this large system memory size. So this is going to be interesting and be able to do some interesting workloads, which definitely on integrated graphics, but also even the discrete graphics, which was not possible because of the system memory size. When it comes to DDR, yes, so our 16-core 4xe can support the highest, both 4xe and 12xe can support the highest memory speeds in terms of DDR. The 8-core, we are validating a lower speed just because we have cheaper like board configurations, etc., offered to OEMs. Now, if they're building a compatible board and they're doing some extra validation, there might be some higher memory speeds achieved. But in general, that is a reason where the lower configuration will have slightly lower memory speeds.
Sure. Yeah, I'm just showing actually the family here as it breaks out with speeds and feeds as well. So you guys can map that in. You can see LPDDR5X on the far right for the 16-core 12xe unit. So good stuff.
And a lot of this was optimized, or we chose the right memory speeds, or we wanted to make sure 12x, because our focus was getting the real life world applications, right? Like I talked ton about peak tops, but as everyone knows, it's not about how many peak tops you have and what you can do with each of those peak tops. And a lot of effort has gone with working with ISVs, and you'll see a lot of these performance as we get closer. This was again one of the choice points to be able to go put that LPDDR memory and higher speeds so that you get the right level of bandwidth, so you can go optimize for some workload. So there is carefully thought through feature sets across the board to be able to optimize real life application performance whatever we have. So every tops we have, we wanted to make sure we put to work and get the best possible application performance.
Sure. Large memory pools like that, you're obviously trying to accommodate things like the latest large language models or what have you on device. So that makes perfect sense as well, right? Is that part of the, I guess, the modus for having some of those big memory, installations, or 96 or 128 gigs of memory?
Yeah, especially on the LP side, I think Marco probably saw some demos as well. There were some agentic AI workloads where you will have big large LLMs which you're able to store in the system memory and take and run from it, and that was one of the reasons why we have large memory sizes.
Got it. Okay. All right. What's next on our hit list, Marco? You want to talk XE graphics, or we have one?
Yeah, let's go graphics.
In the chat?
We have a quick, just a quick comment from Enoch on YouTube. It says the 12xe variant is LPDDR5X only, and there's a reason for that, right? That is the most powerful GPU in the lineup, and you want to feed it as much as possible. So Intel put a guideline in place that most powerful GPU should have as much memory bandwidth as possible. So that was the reason for that. Am I on point there with
Correct.
that explanation?
Absolutely. Yeah.
Gotcha. So
Okay.
So let's stick on XE3, right? Because it's first we'll do a real basic explanation for like the real nerds that follow the channel. We were along for the ride when the first ARC GPUs launched. And, we heard all the code names, Alchemist, Battle Mage, Celestial. Even though this is XE3 branding, it's not necessarily, so we have Battle Mage discrete GPUs. This is not necessarily the next generation, and they're going to be, it's newer than Lunar Lake, but not Celestial. So they're going to be branded in the B series arc. Can you just explain some of that just for clarity so people understand where it fits in the GPU stack?
Sure. I mean, we constantly want to make sure we are making improvements both on hardware and software. When it comes to branding it, that's always an art rather than a science, so to speak. So it is going to be called in that B series realm, B series. However, I can touch upon some of the quick improvements we did from what you see on XE2 to XE3. So first of all, we are increasing our cache sizes, especially at L1 and L2. L2, we are almost doubling our cache size. That will definitely help. Similar to the CPU side, it's going to reduce your need to go back to the memory. So it's as almost as if you have like 30% more bandwidth, because you're 30% of the time you're actually not going to the memory, and you're able to be you're using the cache. So that helps with the initial part of, let's say, an API latency. Now, if we have also made our RT cores more efficient, so more efficiency when it comes to our RT cores. We have variable register allocation. This helps in our vector engine. This is for all the nerds out there. This is the muscle of a GPU when you're running games. We've made sure that there are some feature sets so that you can utilize more of that vector engine. This helps with some of the newer rendering techniques. So you'll get much better performance on newer rendering techniques. So all of this put together, from just XE2 to XE3, you will see better gaming performance core to core. Now, on top of that, of course, from what we had on Lunar Lake, we have increased our size of the number of XE cores as well on 12XE. So you're getting 50% more XE cores on the 12XE variant, which means you will have more of it. So you're able to do even more.
Awesome. And, you know, in terms of, you guys released a video yesterday talking about the 12XE core GPU kind of setting the bar for iGPUs. When these finally hit market, how do you expect this particular GPU configuration to compare to competing offerings that are out there?
So you're going to see significant uplifts from where Lunar Lake was. So already when Lunar Lake came out, it was Lunar Lake provides about 1080p medium settings type of gaming experience, running multitudes of AAA titles. So we didn't have to count the number of AAA titles with a single hand. There was plenty of games. All the games ran, so there was tons of compatibility. But also we brought that 1080p medium settings AAA game level of performance with Lunar Lake. Come Panther Lake, you have about 60% better performance than where you had on Lunar Lake itself. So that means you're able to run even more higher detail. So think of it as 1080p high settings. You will be able to get very high FPSs with Panther Lake itself. Now, that would be the native part of the comments, and we will have a lot more comparisons performance as we get closer. But on top of that, I think you called out with XeSS, we have multi-frame gen. This has made the visual experience of your super sampling a lot more smoother. That means you're now able to, again, push out that FPS at the higher details as well if you turn on XeSS. So this is on top of the native. All my previous 1080p high was on native comment. Then on top of that, you get your XeSS boost if you wanted to use it, and it gets smoother with some of the other software features we are adding.
Gotcha. Yeah, you guys have been on a tear in terms of, not only adding features to the software, but just in general improving the experience with Intel GPUs. Like it's been really interesting to watch, and that 12XE variant, it's going to be interesting to see how that compares once we get it in our hands. Really looking forward to it. Just one quick request. I know you said you guys are going to release tons more benchmark information in the coming months. Hold some back, save some for us for the Let us put some of that stuff out there.
So because Marco said we're going to release only a little bit, and then
Perfect. Perfect. That's exactly
Wow.
what we need. That's nice.
Hey, I hate to interrupt, but did something happen to the stream when we drop it all? Because I had technical difficulties. I think you all kept rocking. Oh,
yeah,
good.
I think we're good. Nish was rolling. We're still live. You dropped off and came back in, but I think we're good.
All right, excellent. Well, so we're in XE3. We're talking about significant gains in performance there, Nish. Can you, I guess, maybe, I don't know, sort of imagine some of the other devices that perhaps might be interesting for Panther Lake? And I know you can't comment on products that aren't announced yet or anything like that, certainly from your partners. But if you think about XE3, the potential impact it makes on integrated graphics and that landscape as a whole, are we talking enabling new devices and form factors? I mean, for example, handheld gaming right now, super big, super hot. Folks are, Steam Deck and ROG Ally and all that stuff. What are your thoughts there? Is it ripe for that space as well?
So I think if you followed all the breadcrumbs, we have very efficient CPU architecture. We have software with like Thread Director, which can pin a lot of the threads to your eco, freeing up resources to be able to give resource to the other engines. And you have a very large integrated graphics. And you have NPU, which can take and run some of these features at low power where it's enabled. All of that lends to gaming in low power and being able to give tons and tons of battery life without compromising that performance. So we are looking at multitudes of form factors, including handhelds. So Panther Lake is going to go into tons of new form factors and even beyond PCs. I think in some of your articles you covered it. It's going to go into robots. It's going to go into other things. So our embedded team is hard at work at scaling this out into other form factors too. So you are going to see Panther Lake in multitudes of form factors, but it lends itself really nicely for handheld gaming.
Sure. All right. Well, thank you. That was about as much of an answer on that topic as I expected from you, because it's early and I know you can't go certain places. So appreciate you humoring me on that. We've got more questions coming in on this, by the way.
Yeah, so I'm going to pop one on the screen. Alva Jonathan, I'm sorry, I hope I pronounced that properly. Your first question about XE3 versus XE2 and Battlemage, he just answered a few minutes ago. So when the stream ends, just rewind a few minutes back. But your second question is actually a really good one, and I don't know the answer, so I would like to ask it. Nish, do you know if you can have VSync enabled with multi-frame generation? I know that's really getting into the minutia, and I didn't ask that when I was out there. So we can always follow up, and I can put a comment in. But if you know, it would be great.
That almost might be a tab question, but go ahead, Nish, see if you can field it.
Yeah, I don't know top of my head, and I think there might be some interferences. So I think we should get the answer and respond back. That would be ideal. But I can see some conflicts with it. So. But let's get the actual answer in. I don't want to say something that I'm not 100% sure about.
Oh, good.
Gotcha.
Oh, good.
Yeah, I was so one of the demos, again, that we talked about earlier, in that demo, with multi-frame gen enabled at 1080p with a modern game, the laptop was breaking 200 frames per second, right? So if you want VSync enabled, assuming it's even possible, unless you have a super high refresh display, what's the point, right? So yeah, let's keep that in mind.
There you go. we've got Tap fans in the audience too. One of these days we got to get Tap back on the show because he is a very good interview and an interesting fellow to talk to. Your partner in crime, Tap there, Nish.
Yes. He is definitely a fellow in many ways, as it is.
Yes, he's an Intel fellow. Yes. All right.
Should we talk about some of the unsung heroes of laptop platforms quick? So
yes, please do.
In terms of I/O, right? You guys are known for some of the best Wi-Fi. You guys have leading edge Bluetooth on the platform. The two different configurations. Some have 12 lanes of Gen 5. One has 20 lanes of Gen 5. Obviously, we talked about Thunderbolt 4 earlier. Let's talk about some of the I/O that Panther Lake will offer.
Sure, I'll stretch the question to platform capability. So in terms of the platform capability, so since you started with Wi-Fi, I'll start with Wi-Fi. I mean, Wi-Fi is getting more important than food for many of us for obvious reasons, and we definitely continue to have the best, let's say, reliability, transfer rates, and what are obstacles you put in. So if you have 3 different walls in basement, all of those tests, we continue to be the gold standard Intel Wi-Fi. On top of that, specifically with Panther Lake, we have a couple of other features which we've added, which is in terms of Bluetooth with Auracast. Now you can listen to multiple, let's say, Bluetooth devices on the same device. You can connect multiple Bluetooth headsets. So if you're on a plane, you want to watch something with your partner, and you both want to have different headsets and watch the same thing, now you will be able to do that. So that's one of the new features which we have. And another new feature is our Bluetooth range is doubling with Panther Lake compared to previous generation, but significantly higher if you compare to competitive solutions. So you hands down are going to have the best PC, let's say, Wi-Fi experience you can get when you get these Intel Wi-Fi with Panther Lake. So first, check in terms of Wi-Fi. So Maslow's pyramid, higher than let's say food. The other one, I'll touch on the other things too, but I also wanted to mention IPU, because we all spend more time in front of a camera than in vacation these days. So certainly having a very good camera experience is important for a lot of us. And with our new IPU, like I mentioned, with some of the AI enhanced feature sets, we are able to give much better quality videos, even in very low lighting. And also on top of that, there is low power. So there's an generation technique for I forgot SHDR, which will consume much low power. So there's a ton of improvement. It's about close to 1.5 watts lower. So a ton of improvements on giving best quality camera experience, but at much lower power. Now, if you go back to the other slide, sorry, I can quickly, I can talk about media to high level.
Sorry, I picked the wrong one.
Oh, no, it's fine. Media, we have tons of new codecs, which we are including. So AVC is the next gen of next gen AVC we have, and AVC encode and decode. So there's plenty of new codecs, which is future-proofing you. So a lot of the streaming vendors are going to move to, but also encode and decode with current existing popular codecs as well, which is available on Panther Lake. So we go back to the actual PCIe lane. So I think I talked about the PCIe lane. The 16-core 4xe has 20 PCIe lanes, along with our 12xe has 12 PCIe lanes. So that's the number of I/O ports directly. And this is a combination of Gen 5 and Gen 4. So as you can see, the 12xe and the 8-core variant has 8 Gen 4s and 4 Gen 5s. We also have 10 USB ports, and up to 4 Thunderbolt ports included. So this is the platform controller tile is pretty common across with the variants of the PCIe lanes. So if you see what's here, you're going to get similar things with the 8-core and the 16-core 4xe variant. The only difference is the 16-core 4xe variant will have a lot higher, like I mentioned, higher PCIe lanes.
Cool. Very cool.
Should we drop a bomb on the conversation because we're running out of time?
Yeah, we're running out of time. We might as well give him the lightning round, right?
No, well, I think I have to ask. I don't think we're going to get much out of you, but we have to ask because I'm sure lots in the industry are eagerly awaiting information. You guys recently announced a partnership with NVIDIA. Any commentary you can provide about that partnership? What kind of fruit may come from it? What it means for Intel's future GPU development? Anything that you can add to the conversation?
Sure, let me tell you all about it.
Yes,
He may have to kill us, but it's okay.
So, I mean, first of all, we are super, super excited about the partnership. I think you saw how the overall industry is rallying behind it, how both CEOs, both Lip-Bu and Jensen were super excited. So we are very excited. We are definitely going to continue to work through it and share more details in the future. But all I can say is we are very excited. This is going to be opening up new possibilities for us. It's going to be additive to everything else we are doing, and it will open up a lot of new possibilities. So stay tuned, but super excited. I couldn't be more excited. The only thing is more exciting is Panther Lake. So, you know.
Fair enough. And I think you mentioned a word that kind of sticks for me, and you know, and I'm speculating as, you know, an industry veteran with Marco here for over 25 years, God help us. And that is, you said additive. And so I think folks need to remember how important integrated graphics, for example, are to products like Panther Lake, and you know how GPU development needs to continue in that regard. And so, you know, I'm speculating. I know you have to, you know, walk the line on what's public and what's not public information right now. But let's think about that, folks. It's you know, it's been core to Intel graphics, I should say, have been core to Intel products like Panther Lake for a very, very, very long time, for many, many generations, right? So,
absolutely, and a lot of the investment and stuff we've done with Panther Lake, you can see from Luna to Panther with that integrated graphics, because that integrated graphics engine is pretty important, obviously, for gaming and traditional graphics workloads, but also AI. There is a lot of things you can do with that bursty performance. So having that combination, and our XMX engine, perf per watt, is one of the leading AI engines out there when it comes to a graphics accelerated AI. So we will continue to leverage that in our portfolio, like in Panther Lake.
Great stuff. Should we bid poor Nish adieu and let him get back to actually working his day job?
I think so. We passed the hour mark, so I think we've taken up enough of his time here.
Yeah. Nish Neelalojanan, thank you so much for your time and the insight you gave us today. It was a pleasure talking with you. Marco, do you want to take care of some housekeeping before we close?
Sure. You know, as usual, if you like this conversation, we would greatly appreciate it if you liked and subscribed to the channel. We're always trying to build the YouTube subscribership. So do us a solid, hit that like and subscribe button. And if you have questions that, you know, if you didn't catch us live and you still have questions, throw something into the comments on the site. We can always follow up later and reply to you there. And obviously, please hit hothardware.com. We only covered really a small fraction of the information that was disclosed at Intel Tech Tour 2025. So check out our article on the site. Check out the news page. We post, you know, dozens of articles every single day. And please, you know, support independent publishing. We are one of the last independent tech publishers online, so we appreciate your support in that regard. And with that, you know, you can find us anywhere on the web. We're basically on every social platform. And with that, I think we can bid you adieu.
Yes, Nish, thanks so much for your time today. It was great meeting you and great chatting about Panther Lake.
Oh, thanks for the opportunity. I had a lot of fun. Thanks so much.
Awesome.
Absolutely. And have a great weekend, everybody. And thanks for stopping by.